The main bonding jumper should be located on the service side of the ungrounded conductor before the neutral current transformer. In a ground fault condition, the main bonding jumper provides a low resistance path for fault current to flow back to the source. This is important because it allows the ground fault circuit interrupter main breaker to detect the imbalance between line and neutral currents and subsequently trip accordingly. If the main bonding jumper were located on the secondary side of the neutral current transformer, the fault current would not flow through the current transformer. As a result, the ground fault circuit interrupter main breaker would not receive an accurate measurement of the fault current. This inaccurate measurement could result in the breaker failing to trip, even in the presence of a ground fault. The presence of the neutral current transformer before the main bonding jumper does not affect the normal operation of the ground fault circuit interrupter main breaker. The current transformer is specifically designed to measure the imbalance between line and neutral currents. When it detects a ground fault, it sends a signal to the breaker, prompting it to trip. According to National Electrical Code 250.6, A. The grounded conductor must be bonded to the equipment grounding conductor at the service entrance or at the first point of connection to the grounded circuit conductor within the premises. Furthermore, National Electrical Code 240.21 B states that an overcurrent protective device must be installed in each ungrounded conductor. Also, National Electrical Code 215.5 indicates that circuit breakers with adjustable trip settings shall only be used if used as service equipment and shall be set at the rated current value of the equipment served. Therefore, based on these code requirements and the reasons stated, the main bonding jumper must be located on the service side of the ungrounded conductor before the neutral current transformer. Firstly, proper placement of the main bonding jumper is crucial for effective ground fault protection. Secondly, the correct location ensures accurate measurement of fault current by the current transformer. Thirdly, compliance with the National Electrical Code is mandatory for safe and legal electrical installations. In a 480 volts, three-phase system, the consequences of improper grounding can be severe, potentially leading to equipment damage or even electrical shock hazards. Understanding the role of each component, including the main bonding jumper, the neutral current transformer, and the ground fault circuit interrupter breaker, is essential for ensuring a safe and reliable electrical system. The main bonding jumper's primary function is to provide a low impedance path for fault current to return to the source, enabling the ground fault protection system to operate correctly. The ground fault circuit interrupter breaker is designed to detect small imbalances in current, indicating a ground fault condition. When such an imbalance is detected, the breaker trips, interrupting the flow of electricity and preventing potential harm. The current transformer is used to measure the current flowing in the neutral conductor. Its output is used by the ground fault protection system to detect ground faults. In summary, the correct placement of the main bonding jumper combined with the proper functioning of the ground fault circuit interrupter breaker and the current transformer is critical for ensuring electrical safety and code compliance in a 480 volts three-phase system. By adhering to the National Electrical Code and understanding the principles of ground fault protection, electrical professionals can create safer and more reliable electrical installations. This is achieved by ensuring that the ground fault current flows through the neutral current transformer, thus providing an accurate reading of the current flowing in the neutral conductor and ensuring proper operation of the ground fault circuit interrupter breaker. When a ground fault occurs, current flows through the fault path back to the source through the main bonding jumper. If the main bonding jumper is incorrectly located on the secondary side of the neutral current transformer, a portion of the fault current bypasses the transformer, leading to a misreading or a complete failure to detect the fault. This scenario renders the ground fault protection system ineffective, increasing the risk of electrical hazards. The National Electrical Code Section 250 provides comprehensive guidelines on grounding and bonding requirements for electrical systems. These guidelines are designed to minimize the risk of electrical shock and fire hazards. Compliance with these requirements is not only a matter of safety but also a legal obligation. In addition to the location of the main bonding jumper, other factors can affect the performance of ground fault protection systems. These factors include the quality of the grounding connections, the proper sizing of conductors, and the correct settings of the ground fault circuit interrupter breaker. Regular inspections and maintenance are essential to ensure that the ground fault protection system is functioning correctly. This includes testing the ground fault circuit interrupter breaker to verify that it trips when a ground fault is detected. It also involves inspecting grounding connections for corrosion and tightness, as well as verifying that conductors are properly sized and installed. Furthermore, it is essential to keep accurate records of all inspections and maintenance activities. These records can be used to track the performance of the ground fault protection system over time and to identify any potential problems before they become serious. A well-maintained ground fault protection system is a critical component of a safe and reliable electrical system. It protects people from electrical shock, prevents equipment damage, and reduces the risk of fire hazards. By following the National Electrical Code guidelines and implementing a comprehensive maintenance program, electrical professionals can ensure that ground fault protection systems are functioning effectively and providing the protection they are designed to provide. Remember that ground fault circuit interrupter breakers with adjustable trip settings as per the National Electrical Code 215.5 should only be used if they serve as service equipment. If they are used as service equipment, they should be set at the rated current value of the equipment being served.